Hi, this is your lesson for Unit 7, and this is actually going to be for Unit 7, Lesson 4 video notes. If you don't already have this printed out, you can pause the video, go print it out, go print out a copy for your friend, or take the time to pause the video and write down the information for the opening this classwork exercise, this background, and then this dot plot. It will be important. It will help you make sense of the material, so take the time. Otherwise, you can title your notes, Summarizing Deviations from the Mean, and it might be easier if you print it out and follow along. You're going to notice we're not going to do a lot of math, a lot of writing though. Summarizing deviations from the mean. What does the word deviations mean? Deviations mean how far away something is. When you deviate from a conversation, you go off on a tangent. When you deviate from a road, your car veers off the road a little bit. And the mean is, of course, our buddy average. So our lesson is about how we can describe something and how far away it is from the average. That's the whole point of this video. Exercise 1. A consumer's organization is planning a study of the various brands of batteries that are available. Hopefully not AAA batteries, but something cool like Tesla batteries or like Prius batteries. As part of its planning, it measures lifetime, how long a battery can be used before it must be replaced for each of the 6 batteries of brand A. Oh, this one? Oh, I want brand A, brand A, brand A, brand A, brand A, brand A. There's 6 of them. And 8 batteries of brand B. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Does one brand of battery tend to last longer? Let's just skim this first. What is happening here? You can make little notes on here. I'm just gonna type. I'm just gonna type a little bit. What do I see? I see that the range is bigger for brand B. I see that brand A lives are more clustered. That's about what I see right now. I just scanned it. I don't even know what these questions are yet. 1. Does one brand of battery tend to last longer, or are they roughly the same? What calculations could you do in order to compare the battery lives of the 2 brands? Well, if it were to last longer, they would all be clustered like in 120, and then they'd all be clustered in like 90. Then we'd be able to tell. But because they're so spread out, because there is a good amount of variability between both brands, I cannot tell which brand will last longer. Because even though there was like a couple of points that are like around 120, these aren't that far off, and they also have inconsistently batteries that are like below 70 hours, so I can't really tell. In order to calculate battery lives and compare, I can use the mean and find its deviations. The more it changes, the more inconsistent it is. The bigger the deviation from the mean, the more inconsistent. Do the battery lives tend to differ more from battery to battery for brand A or from brand B? So we're just looking at brand A. Do they differ a lot? And then we're just looking at brand B. Do they differ a lot? Brand B batteries look like they differ more. This is how I'm answering my questions, and this is how you can answer it in the classroom. A lot of you like to answer the question right away. Brand B batteries look like they differ more. There's the answer to the question. However, that's not enough. You should provide at least 2 pieces of evidence or information that you can pull from the graph to support your answer. You can really answer anything as long as you have support. If you can't find the support, your answer is probably wrong. Okay, so here's one reason why. Brand B has a larger range than brand A, meaning more difference in battery life. Brand A is more clustered together, which can mean more consistent battery life. Two pieces of information. I wrote my answer. I wrote two pieces of information. Best way you can answer it. Would you prefer a battery brand that has a battery life that does not vary as much? Why or why not? Well, I prefer having consistent batteries. And on them to work for the amount, for the entire amount of time I use them. Which doesn't really make sense, but it makes sense to me. I depend on batteries. I do not want my phone battery to last 1 hour one day and 24 hours or 23 hours the next day. I'd rather know that it's always going to die at like 16 hours. I just prefer consistency. Okay, the table below shows the lives and hours of brand A batteries. This is from the plot. You see how it says this is around 83, and that says 83, 94, 96, 94, 96, 106, 113, 114. Deviation from the mean. Oh my goodness. Calculate the mean. We're going to add up all 6 of these numbers and divide by 6. Ready? 83. Whoa, turn that off. 94. Look. 96. Feel free to follow along at home on your own calculator. 106. 113. 114. 606. 606 divided by 6. Well, that's just going to equal to 101. Okay. Deviation from the mean. The mean is 101. Cool. Let's find the deviation. The deviation is going to be our actual number, like in this case 83, and then we're going to subtract 101. So same thing, 94 minus 1, that'll give us negative 7. 96 minus 101, that'll give us negative 5. 106 minus 101, I can do that in my head. 113 minus 101, remember I'm subtracting the mean. Oh yeah, just like something about the mean. This is 12. Oh my gosh. Oh no, 5 plus 5 plus 12. And this is going to be plus 13. When we talk about the mean, this is how it's going to be written a lot of times. The mean is going to be x bar. Bar. Like B-A-R. Bar. X bar is equal to, and then you write the mean. So if you see x bar, then that means the average. Okay. We did that. Here's the most important thing today. Okay, this table shows the battery lives and deviations from brand B. Cool. Negative numbers, then it's positive numbers. So when it's less than the mean, the deviation's negative, and when it's greater than the mean, the deviation's positive. Okay, so find the sum of the deviations. This is the most important part of your notes from both data sets. What do you notice about the sums? The sums of the deviations? Okay. Let's add up the sums of the deviations. Oh, where? Don't go. Okay, let's add up the sums of the deviations. Minus 18 plus minus 7 plus minus 5 plus positive 5 plus 12 plus 13. And we get, any predictions? 0. Well, when the deviations are added, they sum to 0. This means the mean is the center anchor or the balance that is the average for all the data points. Basically, the mean tells us a lot because it tells us the center. And then if we know how far away we are from the mean, we're going to learn about more what that means too. But this is the most important thing that you can take from the video. When the deviations are added, they sum to 0. Okay, next video. Bye. Oh no, I crossed it out. Bye.